Selamat sejahtera to all my respectful panels. Myself Eswaran Thiagarajan and my metric number is B051810144. I am a 4th year student from BMFG 3/1. Today I am going to do my video presentation of PSM2 and my title is Synthesis Bismuth Telluride-Graphene Nanocomposite Electrodeposited Film with Cyclic Voltammetry Analysis. Before I am starting my presentation, I would like to thank my supervisor Dr. Khairul Fadzil bin Samat and a master student named Afif Alias, where both are them guiding me to finish my final year project. Okay, let's see the introduction for my project. In my project, we must know what is thermoelectric generator. The TEG device where the electric energy is produced directly from the heat energy. They are also called Seebeck generators since they use Seebeck effect to produce the power. This is the formula for the figure of merit which related to my PSM project. The figure of merit is used to determine the efficiency of thermocouples and thermoelectric generator. In this formula, we also need to know the main three thermoelectric properties which are Seebeck coefficient, electrical conductivity and thermal conductivity. The three electric properties are mutually dependent. The higher the ZT value, the more is the thermoelectric material and the better the TAG. To increase the ZT value, we should manipulate the thermal conductivity, electrical conductivity and Seebeck coefficient. We can increase the ZT value by increase the Seebeck coefficient and electrical conductivity or either decrease the value of the thermal couple of the conductivity. These are my problem statement for my PSM project. The first one is currently the usage of Internet things are increasing all over the world which are directly related to usage of thermoelectric such as portable or self-power energy source. The second thing is the usage of bismuth telluride film micro energy harvester and sensor are increases. The third one is bismuth telluride in film condition as a low ZT value when compared to the bulk condition. The fourth one, it is hard to enhance the ZT value bismuth telluride film, which includes all the three thermoelectric properties, Seebeck coefficient, electrical conductivity, thermal conductivity, seems they are mutually dependent. The fifth one is low ZT value will reduce the thermoelectric generator efficiency, which is the ratio between the electrical power produced and the heat flow. The last one is the synthesis composite film will be increased the Z value. Okay, let's see why graphene need to mix with the bismuth telluride. Graphene used to improve the power factor, which is the nominal of ZT, by increasing the electrical conductivity. Graphene is most well-known two-dimensional filler that has remarkably high electrical properties. These are my objectives for the PSM project. The first objective is to prepare the electrolyte solution of bismuth telluride for electrodeposition process with good depression and suspension of graphene. The second objective is to synthesize pristine bismuth telluride film and bismuth telluride nanocomposite film with inclusion of graphene up to 5% by use the three electrochemical system. The third objective is to analyze surface morphology and chemical composition of pristine bismuth telluride film and the nanocomposite film with inclusion of graphene. In the methodology, this is my flow chart and the chart of procedure for film synthesis. From the flowchart, you can understand what I am going to do in my project. The first thing is preparing electrolyte solution by using the graphene, bismuth oxide, telluride oxide and nitric acid. Then the second process is synthesis film through the 3 electrodeposition process. Finally, do film characterization by the fabricated film through scanning electron microscopy and energy dispersive X-ray analysis. In another chart, you can see the procedure of film synthesis steps. According to the flowchart, the first objective successfully achieved by prepare the electrolyte solution for the pristine bismuth telluride and graphene inclusive bismuth telluride. For prepare the solution, we need dilute 1.5 gram bismuth oxide and 1.15 gram telluride oxide into the nitric acid. Then dilute the acid bismuth telluride solution with 1000 ml of distilled water to prepare the pristine bismuth telluride solution. This step will produce pristine bismuth telluride solution. From there, we take 250 ml of pristine bismuth telluride solution and add graphene with desired weight percentage. Finally, the electrolyte undergoes magnetic stirrer and sonation until the graphene dilute with good depression and suspension in the solution. Make sure the graphene fully dilute in the solution and no aggregates found in the electrolyte solution. To achieve the second objective, I need to conduct electrodeposition process. This is set up for the 3 electrode cell for film fabrication process. Nanocomposite film were synthesized by the conventional 3 electrode cell system. The pristine bismuth telluride film will be synthesized through the same method of electrodeposition process as reference to compare the thermoelectric properties of the nanocomposite film, which inclusive with the graphene. In the set 3, the cyclic voltammetry on both bismuth telluride and graphene inclusive bismuth telluride will carry out study of reaction mechanism of deposition, especially on the working electrode and to determine the appropriate range of potential electrode deposition. In the electrode deposition process, we need to ensure all the parameter process shown in the table above. The main thing we need to consider is applied potential and time taken for the film synthesis. The electrochemical co-deposition process is conducted without applying it on the electrolyte solution and potentially performed at negative 60 mV in a pulse deposition process. Deposition process was monitored the target thickness of the deposit film. Each of sample undergoes the deposition process for 120 minutes. All these parameters for the deposition is kept same for all the 4 samples. To achieve the third objective, the sample need to undergo characterization technique. The first image shows that the substrate with deposit of 5% graphene nanocomposite film, and the second image is sample preparation for the EDX analysis. I use 2 characterization techniques to complete my third objective. The characterization technique I use is SEM and EDX. From the SEM technique, I can identify the morphology structure for the pristine bismuth telluride and graphene inclusive bismuth telluride. For the SEM parameters, the magnification set as 5000, 10,000 and 15,000. Then I conduct the EDX technique to identify the chemical composition of the sample. Here I use the mapping method to determine the composition in my sample. Okay, let's see the part of result and discussion. For the result and discussion, the CV analysis were conducted. The cyclic voltammetry on both bismuth telluride and graphene bismuth telluride were carried out to study the reaction mechanism of deposition, especially on the working electrode, and to determine the appropriate range of potential electrode deposition. The figure shows CV analysis for electrolyte that contain pristine bismuth telluride ions and with added graphene nanoparticles. The trends and values reduction did not change significantly. The deposition of bismuth telluride occurred when the electron were transferred as bismuth ion and telluride ion at the working electrode surface. With the graphene nanoparticles, the electrolyte solution at the second reduction peak was initiated when potential value was start hitting negative 350 mV and became the maximum at the negative 500 mV. The study CV were brought appropriate decision to apply the potential in electrodeposition for the graphene inclusive bismuth telluride. The value of negative 60 mV was used to fix the parameter for electrodeposition for nanocomposite instead of negative 500 mV due to better morphology growth and the deposit film. These are my SEM results. The first picture A shows a typical growth of electrodeposit pristine bismuth telluride surface crystal structure named as plate-like structure and called as a needle-like structure. The microstructure of the nanocomposite film shown as a B is the typically needle-like shape but it much smaller grain size. The change of size characterization inclusive of graphene nanoparticles in bismuth telluride affecting the size of the crystal structure. A finer scale is represented in the smaller image, which shows the visibly much smaller needle-like crystal of the nanocomposite compared to the pure bismuth telluride. The smaller structure growth tends to produce lower porosity size and denser surface structure. The faster formation of bismuth telluride crystal during the electrodeposition supposedly happened due to effect deposited graphene nanoparticle that act as a catalyzer which enhance the electron transfer to the bismuth telluride ions through them. Then I conduct the EDX analysis. From the EDX analysis, I able to find out the chemical compound in the sample. These are the composition of elements in the graphene inclusive bismuth telluride nanocomposite film. The composition has been analyzed by using the EDX. The highest weight percentage of graphene in the nanocomposite film was to be 9.98%, but it caused huge number error in the atomic percentage of the bismuth telluride. It means the ratio of the bismuth telluride composition are out of limit. So the optimization graphene deposit in this study is 6.08 weight percentage. The carbon nanomaterial content in the bismuth telluride nanocomposite deposit film is optimized and increase the electrical conductivity, which directly boost the ZT value. In conclusion, the three objectives were successfully achieved. First, the electrolyte solution with inclusion of the graphene successfully prepared with good dispersion and suspension. The second one is pristine bismuth telluride and nanocomposite film were fabricated by the three electrode cell. Lastly, SEM and EDX analysis successfully done. Up to 6.02% graphene has been effectively deposited in the nanocomposite film as the carbon weight percentage recorded from the average value of the EDX analysis. For the future work or recommendation, to analyze the film evolution CPA coefficient, electrical conductivity, and the thermal conductivity. Then to study the wide range of nanocomposite and nanocellulose that can be incorporated with the bismuth telluride film so that the thermoelectric performance can be improved. Okay, that's all from me. Thank you all.